rational function, I guess the best way to talk about it is when they talk about graphing rational functions look like this. Y equals some number. Let's just make one up here. 7 over x plus 2 plus oh. Now, let's just do plus 3, I guess. Okay, now, in order to actually graph this, children, if we were to graph this like in days of old, okay, you would plug numbers in for x and figure out what the letter y is. Now, since you get your choice of the letter x, okay, can I change this? I'm going to change this to make it a little easier.
I have to rewrite it.
I told you, well, there's no reason you can't write in pen. So let's change it to that, just because. No, sorry, wrong one.
Oh! Oh! Now I have 2 scribbles on my paper.
I didn't cross it out the first.
Let's change the 7 to be a 4.
I can make that a bit.
Yeah, see how easy I'm helping you with that. Okay, if you think about this, okay, you get to pick your x values. So, as a general rule, you want to pick something that makes this fraction kind of work out nicely. So on the bottom, what numbers do you probably want to get? How about a 4 on the bottom? What would give us a 4 on the bottom here?
2.
So if I pick x to be 2, I get 2 plus 2 is 4, 4 over 4 is 1, 1 plus 3 is 4. Good with that. What other numbers could I pick? Well, we could probably do 0. If I pick 0 for x, 0 plus 2 is 2, 2 goes into 4 2 times, so 2 plus 3 is 5. What about negative numbers? Somebody throw a negative number.
-2.
Okay, -2 in there. I put a -2 in there. Oh no.
0.
No, I don't get 0.
You get 4 over 0.
You get 3. 3.
I'm waiting
get
for
4.
somebody, please. What happens
You get a
anytime?
-4.
What happens anytime you have a 0
On the bottom.
on the bottom fraction? It is. It's no solution. It's undefined. I was glad somebody picked that because that's a good. That's where we're going with that today. Okay, we're going with no solution there. It's undefined. How about another number?
-4.
Let's do -4. -4 plus 2 is a -2, so I get -2 plus 3, which is, I believe, 1.
That's good.
Give me one more.
-8.
6. -3.
Steph says 6. Let's do that. 6 plus 2 is 8. 4 over 8 is 1/2. 1/2 plus 3 is 3.5. Okay, if I was graphing this,
What was it? 3.5. 6.
if I was going to graph this, oh, I forgot to give you some graphing paper.
I have a ruler.
I can hear
It's
that.
fine.
That's 2, 4, 0, 5. Right here. -2, interestingly enough, here, -2 has no solution to it. So I'm going to do this, ladies and gentlemen. I am going to put a dashed line right there. There's no solution there. It doesn't work there. -4 is 1. Correct? 6 is 3.5. 3, 4, 5, 6. 1, 2, 3.5. I need some other negative numbers just for fun.
-9.
-100.
No, let's do something that works out.
10.
-3.
-3. Yeah, -3 would work out. That's a good call. -3 plus 2 is a -1. 4 over -1 is a -4. -4 plus 3 is -1. I need I'm looking for what I need.
negative.
I want a couple more on the negative side, can I? Can we go, what do you suppose we get if we put a negative 3 in? Oh, we've already done negative 3. 1, 2, 3. How come I moved it? The dot should be here, shouldn't it?
It should be on the other side.
Wait, did I put it in the wrong place?
It should be under the one.
Wait a second.
Put it on the wrong
Let me
place.
get- This dot's wrong?
Yeah, it should be under the negative space.
I'll give it
But now
to
you don't have negative 4 1. That
No,
was
I
negative
just
4
throw
1.
out.
Wait, is negative 4 1 right?
Yeah.
You
No.
have negative
Oh.
5 1.
Oh, no, that's, wait, but negative 3, negative 1 should be 1, 2, 3. I'm sorry, that makes sense. This dot was gone. People are telling me the wrong thing.
I know.
I need, I need a higher negative number. Let's go negative, negative 8, no,
Negative 6.
negative 10.
Negative 18.
Let's do negative 10.
Negative 8.
Fun with,
Negative 22.
negative 10 plus 2 is a negative 8. 4 over negative 8 is negative 1/2, correct? Negative 1/2 plus 3 is 2.5. So at negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I get 2 1/2. 1, 2 1/2. And then
How about
let's do,
8?
I don't think we can do one more. Can I do negative 1 just for fun to show you where this other dot would
How
be?
about negative 6?
Sure.
Yes, let's do negative 1.
Negative 6.
Negative 1 plus 2 is 1. 4 over 1 is 4 plus 3 is
7.
yes. So negative 1 is 7. 1, 2, 3, 4, 5, 6, 7. Now, here is when you graph rational functions, you will always get a graph that looks like this. It may not be exactly like this, but it's going to look very much like this. You see how these lines really don't line up into a line? They do line up into some kind of a half arc, and it's going to look like this. When you graph it out, it's going to look like that. It is a curve. And the other side,
To be the opposite.
on the other side of that line that we said couldn't happen because it becomes a no solution, is another line that is exactly like it, except it's a mirror image and reflection that looks like this. Okay? And as you get closer to those lines, okay, you just get higher and higher up, and it kind of grows exponentially.
Does it
now-
come into a circle?
No, these lines will never actually get to this line here. In addition to that, children, not only is there a line on the x-axis that will never be approached, or could never be crossed, or never gets to, there's also one on the y-axis, and if you see it, it's actually this line right here. Okay?
So we don't count.
Boom, you get this that curves this way, you get this that curves this way. Never will you get y to be 3, and never will you get x to be 2. Now, there lies the word that I'm going to write out for you because it's hard for me to say. It's just, you never see these letters put together in this general way. Those two lines are called the, I want to make sure I spell it right because, you know, no, they're called this. The ASY, this whole thing here, asymptote.
Is that the word?
That is the word that I just,
Oh.
it's just hard to say. Asymptote. Okay. And what are they? The asymptotes.
Is that the word?
Yep.
Wait, is it PT's? What is that?
ASYMPTOTE. Okay, they are the lines. They're like the boundary lines. They're the boundary lines that will be approached but never crossed. They're approached but never crossed.
Boundary?
Yeah, boundary lines. B-O-U-N-D-R-Y, boundary. There's no D-A-R-Y, is it?
Is that the
Yeah, it
word?
is A-R-Y.
Is it boundary?
Boundary. They are the boundary lines that are approached but never crossed.
what's that letter under the line?
Approached but never crossed. Got that? Because then we're going to do the little formulae that gives you those. Somewhere here. Okay. And I don't want to erase this because it's also pretty, but I'm going to maybe I'll draw over top of our line here. Okay. The generic formula, the generic equation for this is y equals a over x minus b plus c. That's just where we use letters to stand for the numbers that are all over there. Because this is where you get your asymptotes from. Okay? The horizontal asymptote, which is this one here, okay, is always going to be where x makes the denominator of that fraction 0. Okay? Which means it's always going to be whatever's opposite of the letter b. Okay? In other words, in this case, the letter b was positive 2. It would be a negative 2. Because negative 2 plus a positive 2 gives you a 0. So you have to think about that. And I don't know what the best way to write that is if you're doing it here, the horizontal asymptote is, just put it in there, whatever makes the denominator 0. Whatever makes denominator 0. And in this case, it's where x equals b. Okay, because whatever number that was, I know it's not so hard if you just do a
Why
couple
are
of
there letters
examples.
that don't give us numbers?
Huh? Because it's true for everything. If you put a number in there, then I'd have to say, well, it's only when x is 2, but it's not. It's when x can be any number that's opposite of that number. That was a positive 2, so opposite of that is, actually it's probably negative.
But that's a negative.
It has to be the opposite of whatever b is.
Is it B negative?
So
Negative.
So we
And
draw
then write this down. Well, you'll get it when we get there. The vertical one. The vertical one is whatever this number is. Remember, see here at 3, where y equals 3, that's where that line was. Is where y equals the letter C. Write that down, because then when I give you an actual one of them, you'll say, oh, that's pretty easy. You got this now? Because I need a new screen. You'll get it. You will get it. It'll be the biggest piece of cake you've ever had.
Do you have to graph?
I'm going to show you. Here's an equation. Y equals 4 over x plus 10 plus 3. Watch how easy this is. Okay, the first thing you do is find your vertical and horizontal asymptotes. Okay? And this is the only thing you need to look. Let's do the easiest one first. Now let's do this one first. Okay? This, where y equals 3, that's going to be your horizontal one. So whatever this number is at the end, you draw a dashed line that goes through y at that point. Whatever that last number is, that's your what y can never be. Okay, y can never be 3.
Wait, I thought it was your vertical one. Because the vertical asymptote is y equals c. Isn't 3c.
Flip that, it should be horizontal. This is a horizontal line, isn't it? Did I write wrong backwards on that?
You said right or wrong backwards then.
Because I just had the-
Wait, what?
Yeah, you did.
Flip these around, put a little arrow here and say this should be here and this should be there. I sided. It's the first mistake I've made pretty much since about 9 o'clock.
Since you started. So about 45.
The other one, the horizontal one, the one that goes up and down, the vertical one. Oh wait, this is vertical, right?
Vertical goes up and down.
Wait, did I say this was horizontal? Did I say this was vertical?
You just said that.
Well, you said that one was vertical.
Oh, sorry. Why didn't you stop?
So
me?
that line is vertical.
This is horizontal.
That's horizontal.
That's the H
Okay,
line.
horizontal equals
So
y.
we don't need
Wow,
to
is
see
this one?
C equals.
Horizontal is this one.
So we were right.
Was I right when I wrote it down? Wait,
No,
did I-
you said the vertical asymptote is y.
Just change
this one will never make the website, just so you know. I'm going to change it all.
So you changed it.
The vertical one is whatever number makes this a 0 on the bottom. So what number would you add to 10? Negative 10. So the vertical one is where at negative 10 x is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you draw a 1 up and down. I guess I should have probably picked a different number there. And once you get those, you don't have to do anything else as far as making a table or anything. You just take this and say it's going to always be that same shape. It's always going to look like this. It's always going to come down, sweep, and go like this. And this one's always going to come down and go like that. So this is the graph of that. We have this little curve shape that looks like this, and another little curve shape that looks like that. And that's all you need to do to show for the graph of that.
That's it.
That is it.
So we don't have to pick any more points.
You don't have to pick any points. You just show the two asymptotes, and you draw the little curvy thing, and you move on with your life.
I just wrote the word life.
Perfect. Is that bizarre or what? Let me throw another one at you. What about y equals 2 over 8 minus x? Or x minus 8, sorry. Y equals 2 over x minus 8.
Is it?
Now don't, there's no ending number there, which should make you think. So what is y not going to be? 0, because you could just put a plus 0 there. So you know there's going to be a dashed line right here on the x-axis, because that's what y can't be. That's where y is 0. What can't x be? Now, what number would make a 0 on the bottom of this fraction? 8. So here at 1, 2, 3, 4, 5, 6, 7, 8 is going to be your vertical asymptote. And then it's always, by the way, for right now, it's always going to be in the upper right and lower left. So don't get confused and put it over here and over here. It's always here and here.
It's never on.
See how easy that one?
It's never opposite.
I'm gonna have to look. There's probably when x is negative and y is negative, but for right now, no. I'm gonna have to look, but they don't show us anything.
Yeah.
It looks hard, but
It is
exactly.
far
it's
too
weird
easy.
how you graph it.
It looks too easy, but it's hard. Alright, so let me give you one
I'm
here.
bad at drawing dashes, so
Y equals 1 over x minus 4. Y equals 1 over x minus 4 minus 2. Graph that one for me, please.
Minus 2.
Minus 2. Oh, frequency distribution. Eventually we get to parts here where was a negative, if x was negative, what would happen there? If x was negative, it might switch it around. We should try.
That's how we're gonna make them. Oh, it's so good.
by the way, the book will ask you for the vertical and the horizontal, or the x and the y. So if they ask you for it, the x asymptote would be 4, where x equals 4, 1, 2, 3, 4, y, because that's where this is 0. So you draw a vertical line there. The y asymptote would be where y is -2. So here at 1, 2, you have a dashed line going this way. And then the graph of it would be, just do this little, as best you can, sort of thing. And it's not exactly, by the way, it's not a perfect circle. Don't make it out here like this. It comes down and makes a sharper curve, and then it flattens out like that. They always have that same kind of shape to it. Where this keeps getting closer to this asymptote, but it will never get there. You know, if you could do it.
So it's like a square with rounded corners.
Yes, but the line never, I guess as you get farther away, it gets flatter and flatter and flatter. But yeah, it's more of a square with rounded corners than it would be a straight arc or part of a circle. Alright, so if I'm not going to give you homework, we're going to look at one more. What happens when x is negative? What if we go 1, what if I do 1 over negative x plus 3 minus 2?
Just negative.
Well, I wanna actually graph this out.
Isn't it just 3 then? Yeah.
What?
Yeah. Isn't it
I know, but I want to see where the points line up on the graph, so I'm actually going to do this one out. I know what my asymptotes are. Those aren't going to change. I know at -2 there's going to be this one, and I know at +3 there's going to be this one. But I want to see if the line ends up being on this side or this side. It'll only take a couple points. What point you say? Let's do 3. If x equals 3, well, that's what we can't have. Sorry. If x equals, wait, can I change this? I can. Let's make that 4. What? If x equals -1, what do I get for y? That's +1, 4, 4, 1 minus 2 is a -1. So I get -1, -1. Here's -1, and here's -1, right? So that does put it on the opposite side, right? In other words, if x was negative, instead of it being in the upper right and lower left, it's going to be in the upper left and lower right. So it's going to look like this. Oh wait. Yeah, it's going to look like this. And
Wait, if it's -1, -1. Oh, remember.
I got confused. What else could I have here? What if I did -4? If I do -4, I get. Why would I do -4? What if I do -7? -7 would give me no. If I just do +7. 7 minus 3, -4, -1, -3. So 7 is 7, -3. So I can't get -3, can I? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Yep, I'd probably do that right there. Enough of that. Alright, go get your reading, please. Why is there no homework today?
We're doing better.